Hi guys, how are you doing? I hope you're doing great. This is Teacher Smile again, and today we are going to talk about Euclidean Geometry. We are going to just summarize the grade 11 theorems. You need to classify these theorems that we are talking about in three categories. You are going to look at three theorems in three categories. The first category will be the center theorems. And in the center theorems, you need to look at three theorems that have something to do with the center. So the first theorem is this one. Given that O is your center, we have AB as your chord, and let's say this is M, and this is 90 degrees. In this case, AM is equal to MB. It's because a line from center perpendicular to a chord bisects the chord. So this is a line from center. OM is coming from center, and then AM is equals to MB because AB is a chord. The second one is X is equal to 2 times Y. Right? This angle X here is equal to 2 times Y if O is the center. This angle X is equal to 2 times Y because the angle at center is equal to 2 times angle at circumference. It may come like this. Sorry about my circles, right? It may come like this. This is still the angle at circumference. This is the angle at center if O is the center. So we still have that theorem. Angle at center is equals to twice angle at circumference. Or it may come like this. Hey, my circles are very, very, very beautiful. Still, this angle here is angle at center. This one is angle at circumference. Or it may come like this. This one is angle at circumference. This one is angle at center. So you need to remember this theorem. What you just need to know is that we need radius. And if there is any angle formed from those two radii, then at the circumference, then this angle is angle at circumference. Radius, angle formed at circumference from the ends of the radii. Here, radius, angle formed from its circumference from the ends of the radii. Here, radius, angle formed at circumference from the ends of the radii. If I am given this line being a straight line passing through the center, the diameter, an angle that is formed there, we say it's 90 degrees. It's 90 degrees. Why is that? Because the reason is angle in a semicircle. And the second one, of course, we need to look at the theorems that have the tangents, right? Number 2, the theorems that have the tangents. Okay, that's why I was saying 3 in 3, if that makes sense. We are going to have 3 in each and every one of the 3 categories. So in this category, you also need 3. The first one with the tangent, remember a tangent is a line that is drawn from outside the circle, touching the circle, but not getting into the circle. Now, at the point of tangency, or where the point is touching the circle, at that point, if you have a triangle that is one of its corners, it's here, like this one. One of the corners of the triangle is at the point of tangents. we have a theorem. This angle here will be equal to that angle inside. This is A, B, let's say C, D. We are saying A is equals to C and B is equals to D. These angles that are opposite are now equal. This one is also equal to that one, right? There's a tangent and a triangle. One of triangle of this triangle is touching at this particular point. So this angle and that angle are equal. This angle and that angle are equal. This is known as turn chord theorem. We have circle, we have tangent, and we have the center here. And then we have a radius. Remember, a radius is a line that is drawn from center. And if this line goes to the point of tangents, remember, point of tangents just mean where the tangent is touching the circle. If the tangent is meeting the radius, this is the tangent that we have, this is the radius that we have. If they are meeting, they meet at 90 degrees. In other words, the tangent and the radius are perpendicular to each other. They give us a theorem that is known as tan is perpendicular to a radius. A tangent and a radius, they are perpendicular to each other. Number C, we may have a circle like this, and then we have two tangents, and this is T. Let's say this one is A, the point of tangent here. The point of tangent here is B. We say that TA is equals to TB, right? The length from here to there is equal to the length from here to there. These sides are equal. Why would they be equal? Because they are tangents from the same point. These are the theorems with the tangent. Then lastly, the theorems to do with cyclic quadrilateral. Okay, a cyclic quadrilateral is a shape with four sides, while all the four corners of that shape are touching the circumference of the circle. This is a cyclic quadrilateral. This one is not a cyclic quadrilateral because one of the corners is not touching the circumference. So all of the four corners should be touching the circumference. We also have the three theorems that we'll need to look at. The first one, A plus B is equal to 180 degrees. The reason is because they are opposite angles of cyclic quadrilateral. We need to know that they are supplementary. That's why we have this. That's one of the theorems. Number B, this angle here and that angle inside are equal. C is equals to A degrees. Why is that? It's because they are, it's an exterior angle of cyclic quad. Then lastly, which is C. Do you guys know a bow tie? Okay, a bow tie is something that looks almost like this, right? And in a bow tie, the angle up here must be equal to that angle up here. The angle down here must be equal to the angle down here if we are in a circle. Therefore, when we see it in a circle like this, always check for that bow tie. The angle up here is equal to the angle up here. The angle down here, they should be meeting. The angle down here is equal to the angle down here. The reason is because there are angles in the same segment, or there are angles subtended by the same chord. And you may ask, which chord now? It's like we have an invisible chord here. Let me draw it. We have an invisible chord here. Yes. So the angles that are subtended by the same chord are equal. So these are the three theorems that we have. Okay, this one, though, we may see a brother of it. We now say that x is equal to y. The reason is because there are angles subtended by equal chords, right? This chord and this chord are equal, so the angles are formed from the ends of those chords. So the angles that they are forming are also equal. Here it was same chord, because this one is same chord. This angle is formed by this very chord, this angle by this very chord. But here the chords are different, but they are equal. They are equal chords. So we don't say same chord here, we say equal chords. But here we say same chord because they are the same. Just doing a recap, in Euclidean geometry, we need to understand three theorems in each of the three categories that we have, which is center theorems. The theorems that have something to do with center, these are the theorems. We just want you to remember them as three, like this. And these are the theorems: tangent, tan chord theorem, tan and radius. They are forming 90 degrees. They are perpendicular to each other. This symbol means perpendicular. And then the tangents from the same point are equal. It's as straightforward as that. Cyclic quadrilaterals. 1, 2, 3. When we want to prove if any random quadrilateral is cyclic quadrilateral, we play along with these theorems. We are going to talk about that. And if you also want to prove if probably a line you are given is a tangent to a circle, you also play with these theorems, especially the tan chord theorem. And I hope you understand. See you next time. Goodbye.